Okay, this is our final lesson, lesson 4, which is on two-way frequency tables. So it's just going to show you how you can use a frequency table. You've seen some of these problems perhaps in previous homework, so maybe you've kind of caught on your own. But just in case, I'll go through this lesson, and this is it. Then we have a review day, and then your test, and then we have exam review, and then your exam, and then it's the end of semester 1. Okay, so two-way frequency tables. Two-way frequency tables can be used to examine the relationship between two categorical variables. So two categories, right? Two categorical variables. Entries in the cells of a two-way table can be displayed as a frequency counts or as relative frequencies. And relative frequencies are just simply a percentage. They're just documenting that information you gathered as a percentage, as opposed to just the counts. Like if you were collecting data, you might do a little this type of thing, right? Oops, that's a frequency count. And then otherwise you have maybe 0.28, which means 28%. That's a relative frequency. Okay, below is the two-way table. It shows the favorite leisure activities for 50 adults, 20 men and 30 women. So here you can see this row is representing all 20 men, and this row is representing all 30 women. And then down we have different categories. The categorical variables are favorite leisure activities and gender. So then we saw that they could choose dance as their favorite leisure activity, sports as their favorite leisure activity, and TV as their favorite leisure activity. So if we read it down, we would say there's 18 people total who chose dance. There were 2 men and 16 women who chose dance as their favorite leisure activity. Or there were 10 men who chose sports as their favorite leisure activity and 16 women who chose sports as their leisure activity, for a total of 16 people choosing sports as their favorite leisure activity. And then, of course, 8 men like TV, 8 women like TV the best. So a total of 16 people like TV, a total of 30 women answered the survey, and a total of 20 men. So this right here is the overall total. So that tells you how many people actually answered the survey. So this row should add up, these 3 numbers should add up to 50, and these 2 numbers should add up to 50. Okay, if we want to change that into a relative frequency table, we're just going to change all of these numbers into percentages. So you say, okay, well there's 50 total, so how do we get 0.04 here? Well, we just take 2 and we divide it by 50. Right, and if you double 50, that's 100, so double 2, you get 4%, so change 4% into a decimal, it's 0.04. So this one here would be 10 divided by 50, well, again, double that to make it out of 100, so that would be 20%, which we would have as 0.20. 8, that's 8 out of 50, double it, so that's 0.16, well, there's an 8 here, oops, which is 0.16 here. Here this is 0.32 because it's a 16. Here it's 0.32 because it's a 16. Right, so I'm just doubling all of these. This is 0.6. This is 0.4. And so when I add right down 0.4 plus 0.6, does it equal 1.0? Yes, it does. 0.36 plus 0.32 plus 0.32, does that equal 1.0? Yes, it does. Does 0.32 plus 0.12 plus 0.16 equal 0.6? Yes, 0.04 plus 0.20 plus 0.16 does equal 0.4. Yes. So this is now just representing, we're saying 16% of women chose TV as their favorite leisure activity. 4% of men chose dance as their favorite leisure activity, etc. Okay, so I think that's what this summarizes right here. Asked us to fill in the blank, which we did. So let's move on to our next page. Okay, now let's just do some practice problems. So it says a public opinion survey explored the relationship between age and support for increasing the minimum wage. The results are summarized in the two-way table below. So here we can see we had age categories of 21 to 40, 41 to 60, and then over 60 years old. They were either for it, against it, or they didn't really care too much. They had no opinion, right? So now when we go down, we have to see here, or we can see that 25 and 20, well, there's 25 people between the ages of 21 and 40 who are for the support for increasing minimum wage. There were 20 for it in this category, and then all 3 of these have to add up to 100. So 25 plus 20 is 45. We subtract that from 100 to get 55. Here we have 20, 35, 15. So 20 people are against it in this age range. 35 people are against it in that age range. So we add these up, 20, 55, 60, 70. So we have a total of 70 who are against it. We have a total of 30 who have no opinion. Well, here's 5 of them, here's 5 of them. That means I have 20 left over who have no opinion. That's going to go here. And then we can go across and add horizontally. So 25 plus 20 plus 5. Well, that's 50 people altogether. Just do your double check. I would double check my math here. So 20 plus 20 is 40 plus 35 is 75. 55 plus 5 is 60 plus 15 is 75. So yeah, now I know I did my math right. Now what is my ultimate total right here? So I add 100 plus 70 plus 30. That's 200. Double check this way. 75 plus 75 is 150 plus 50 is 200. So 200 people total answered this public opinion survey. So now let's answer these questions based on the results of this table. What is the probability that a randomly selected person is over 60? So am I going to look horizontally or am I going to look vertically? Well, you can see the age category goes horizontally. So right here, there were 75 people that were over the age of 60 who answered this survey. So that's the probability of a randomly selected person being over 60. So if I'm going to write it out, it's probability over 60. So that's 75 out of how many? Well, that's 200. And then when I reduce, I get 3/8. Okay, letter C. It says, what is the probability that a randomly selected person is over 60 given that, so now I have a condition, given that they are against the increase of minimum wage. So if I'm going to write that out, it's a probability of a randomly selected person over 60. But given that, remember we write that bar, given that they are against the increase of minimum wage. So what do we do for this? We do the probability of over 60, what's the 60, intersecting against, divided by the probability of against. So where does over 60 intersect against? Well, that's right here. So I have 15 people altogether, divided by just the probability of against. Well, probability of against is this column. So I have 70 people altogether who are against that policy. So it's 15 divided by 70. I can reduce that by 5, and I get 3/16. Okay, let's look at letter D. It's slightly different. What is the probability that a randomly selected person is against the increase of minimum wage, given that they are over 60? So I'm reversing this. So I'm going to say against first, given that over 60. So I'm trying to keep my table which way, so I kind of haven't scrolled down a little bit. So this time it's probability of against intersecting over 60 divided by probability of over 60. So my intersection is still the same. I still have 15. My denominator is what changes. I'm looking at the probability of being over 60. Well, that is just 75 right here, that total. So this time it's 15 divided by 75 instead of 15 divided by 70. So after I reduce, I'm going to get 3/17 instead of 3/16. Letter E, what is the total percent of people against the minimum wage? So what is the total percent of people against the minimum increase in minimum wage? So that's probability of people against it. So what do? We go up here, we look at our our column of against. It's 70 people are against, but 70 out of how many? Well, that's 70 out of 200. Right? It says total percentage, so I'm going to change this to a percent, and I get 35%. So that's 0.35 as a decimal, which is 35%. And letter F, what is the probability that a randomly selected person is either in the 41 to 60 age category or for the wage increase? So that would be the probability of 41 through 60 or for the wage increase. Well, if we're going to write this out, we're going to do the probability of 41 through 60 plus the probability of 4 but I'm going to subtract the overlapping, because in this thing I can see there are people. So if I did 4 and then I did 41 for 60, well, this 20 would be counted twice. So I'd have to subtract the probability of 41 through 60 and 4. Or you could just add the categories together, right? So that would be adding straight down, 25 plus 20 plus 55, adding across, plus 35 plus 20. I wouldn't add this 20 twice, right? But I'm looking at these two things right here. Or we could add straight down and go 100 plus 75 and subtract the 20. So the way I've written it is I would do 100 out of 200 plus 75 out of 200 minus, what was the repeat? It was 20 out of 200. So what do I get all together? I get 155 out of 200, which is 31/40 if I'm reducing. Okay, and finally our last page before you can go about everything else on your own. Here's another small frequency table. Use 2A frequency table to answer the question. So what's not on here is your ultimate totals. So maybe you want to put that in. So this would be the total altogether. So 152 plus 82, well that totals 234. 97 plus 55, that totals 155. So when I add straight down, I get 389. But I want to double check that. 152 plus 97 is 249. 82 plus 58 is 140. And then just double check. 349 plus 180, that's 389. So this is the total number of people who answered the survey, 389. So find the probability that a randomly selected person in the group smokes. So here are my people that smoke. I have 152 people that smoke and drink, and 82 people that smoke but do not drink. So I have 234 people out of 389 who smoke. So this is the probability of people who smoke. Letter B, find the probability that a randomly selected person in the group neither drinks nor smokes. So the probability that they do not drink and they do not smoke. They neither drink nor smoke. Oh, I could have reversed that. That's their order, sorry. They do not drink, do not smoke. So you either put the D prime and S prime, or you put the bar on top, which means not. So this does not drink alcohol is the same as D bar. Does not smoke is the same as S bar. So when they do neither of them, well, here. These people do not drink alcohol and they do not smoke, so that's 58 out of 389. Okay, how about letter C? Find the probability that a randomly selected person in the group smokes, given that, so the probability that they smoke, given that they do not drink. So S, but not D, given that not D. So I'm going to do the intersection of S. They smoke, but they do not drink. That's 82. And I'm going to divide it by just do not drink, which the total of do not drink is 140. And then I would reduce, so I get 41 over 70. And finally, my last one. Find the probability that a randomly selected person in the group smokes or drinks. So the probability that we have a smoker or a drinker. So you're either going to add those columns up, rows up, or you're going to do the probability of smoking plus the probability of drinking minus their intersection of the smokers and the drinkers. So they smoke or they drink. Well, these are the people that smoke, 152 plus 82. These are the people that drink, 152 plus 97. Well, obviously, we're not going to add that 152 twice. So it's just 152 plus 97 plus 82, which I get to be 331 over 389. If I'm filling this out, though, right here, I would have put, this is 234 over 389. Plus probability of drinkers, that's 249 over 389. That's here, and then minus my intersection, which is 152. These people smoke and drink over 389, so it's the same answer, 331 over 389. Or I could have just done the complement of this one right here. Right, these are people that do both, so what are the people that, these are people that don't do either, so this would be the group that would do both, which would be the complement of that, or one or the other, sorry, not Not both, one or the other. Sorry about that. All right, so you're good to go. Stop the video, get started on those problems, and ask your teacher if you have questions. See you later.